Okay, so we're going to look at Chapter 4 here. Chapter 4 is all to do with trigonometry, and we're dealing mainly with right angles, right triangles, so 90-degree triangles. And this is often used in surveying, so that's what the picture here is talking about. Surveyors are holding these instruments called theodolites to measure angles. Typically they're measuring angles and measuring from the angles they can also measure some distances and calculate inaccessible distances to places that they can't normally reach, like top of high towers or across a riverbank. And as long as they form a right angle triangle, they can calculate the distance they're interested in, or the angle. So, solving for angles, lengths, and distances. One thing we've got to remember is how to actually go ahead and label a triangle, and it depends on the angle you're interested in. So in this case we're interested in this angle here, and from that angle everything else is named. All the sides of the triangle are named. So across or opposite from the angle we have the opposite side. Adjacent to or beside the angle is the adjacent, and the longest side is always the hypotenuse. So opposite is opposite the angle, adjacent is beside the angle, and hypotenuse is the longest side. Okay, so we define some ratios here, as sine is the opposite over hypotenuse, cos is of the angle is adjacent over hypotenuse, and tan is opposite over adjacent. And this is what you've learned as SOHCAHTOA. So SOHCAHTOA is your typical SOH, and I'll just get my pen because it's taking too long to do it with the mouse. SOHCAHTOA. So if you remember that, you remember that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. And these are called ratios. So this is the sine ratio for this angle, this is the cos ratio for this angle, and the tan ratio for this angle. And so if you want to know the value of tan theta, you just put the opposite side and divide it by the adjacent side, and you have your value for tan theta. Now that's not the angle, but that's tan theta. And all these are ratios, can be expressed as ratios. So let's go to example 1. Example 1 is talking about these two triangles. And notice that we're given two sides of the triangle in both cases, and it's asking us to find in one case h and in the other case s. So we're thinking about here of using the Pythagoras theorem, and that's where this squared plus this squared equals this squared. Now they've labeled these a, b, and this would be c. And typically we write a squared plus b squared equals c squared. Remember that these little letters a, b, and c are the letters designated opposite the capital letters for the angles. So this is angle A, so this is side A here. This is capital B, angle B, so this is side B, and capital C for the angle, so this really is typically side C when we fill out the formula. So they're calling this side h, so it would be h squared here. H squared is equal to a squared plus b squared, which they've written out here nicely for us and plugged in the values. To get h, we have to square root this, so we have to square root this value, and finally we get our answer for h as 23.2. Now in doing the same for this side here, notice the hypotenuse is always side C. So always remember that. The other two, it doesn't matter which is which, A or B. It doesn't matter, so we can call this side A and this side B. So again, we set up our A squared plus B squared equals C squared. And it's the A side that we're trying to find. So we'll fill that in. Fill in what we know. A squared plus B squared, that means 4.3 squared equals C squared, 9.3 squared. We can move this 4.3 squared to the other side. In doing that, we'll have to subtract it from both sides. So we end up with, squared. So we end up with this calculation, and finally for A, whatever value we get, we have to square root this whole thing. So 9.3 squared minus 4.3 squared. And whatever this value is, we will square root it and we'll finally get our answer to A. Okay. And they'll probably show that answer below. So let's have a look. So part B is calculating inside, and here it is 8.2. Now they're also asking us a couple of other things here. They're saying for us to solve the triangles. Solve. So what does that mean? That means to find all the sides and find all the angles. So here we need to find A and B. Here we need to find T and S as well. So in doing that and finding angle A, notice what sides you have. You have angle A here. Let me just put my pen on this now. Angle A is right here. So when we're talking about angle A, we have the opposite and the adjacent. So if we have the opposite and adjacent, that's TOA. So we have to set up the tan ratio for angle A is the opposite, 7.5 over 15.3. Now that's tan A. We want angle A. So to get rid of the tan, we're not going to divide or multiply or anything. We have to do the inverse tan to this side to give us A. And if we inverse tan this in our calculator, it's sometimes second function tan, or tan to the negative 1. We can do this all in one step and punch in tan to the negative 1, open bracket, 7.5 divided by 15.3, close bracket, and that will give us the answer. And the answer is down below. So looking at that, here's the inverse tan, 15.3 over 17.5, and they find the angle is 41.2. Subtracting this from 90 gives us angle B. So remember that if we have this angle, then we can calculate this angle. These two have to add up to 90, because this is 90 here in the right angle triangle, plus another 90 gives us the 180. So these two add up to these two add up to 90 degrees. So in finding one of them, we can subtract that from 90 to get the other. In the second triangle, they're using the cosine rule to find angle S. So let's scan back here and have a look. So angle S is here. And what sides do they give us? Well, they haven't given us the opposite, but they've given us the adjacent and the hypotenuse. So in that case, adjacent and hypotenuse, we're going to use cos. Cos of the angle, which they're calling S, equals the adjacent over the hypotenuse. And then we have to inverse cos both sides to give us S equal to inverse cos of 4.3 divided by 9.3. Sorry, my 3 isn't very good there. Sorry, bracket all the way down here. and that will give us the value of S when we plug it into the calculator. So let's just scroll down and see what they have. And they calculated it here to be 62.5, doing the same calculation. To get the other angle, 90 minus 62.5 gives us a 27.5 degrees. So we've solved those two triangles. So these are build your skills, and I'll assign which ones to do at the end of this video. I'm moving on to the example 2. We have an angle and we have the opposite. That allows us in this big triangle to calculate either the hypotenuse or this large side here, the adjacent to 26. In fact, that's SQ. So SQ, we'll mark this as SQ. So opposite and adjacent, that's tan. So tan of the angle S is equal to the opposite, 12.5, divided by the value for SQ, the length of SQ. So let's see. In a situation like this, where you have a three-way equation, one thing is equaling a ratio here. These two values, the value on the bottom of the denominator, the denominator here can be switched with this term over here. Let me give you an example, typical example here. If we say that 4 is equal to 8 over 2, you can see we can swap the 4 and the 2. It still holds true. 2 equals 8 over 4. You'll find this for any ratio, three-way ratio like this. So in other words, if we have A equal to B over C, you can switch A and C around, and C would equal B over A. We can show this algebraically the long way, but if you take it from me, that's exactly what will happen each time you try this. No matter what values you use here, as long as this side equals this side, you can swap these two. So we can do this with this ratio right here. So SQ equals 12.5 divided by tan of 26. And now we just plug into our calculator this here. Okay? And it's always, when you're dividing, it's always good to put the denominator in brackets, especially if there's more than one thing. So they've done that right here, showing you a slightly different way from what I've shown. And notice that, oh, what have they done here? Yeah, here we are. Here's the ratio right here that I had set up. If you want to replay the last part of the video, and they calculate it SQ or QS to be 25.6. Okay, so we found that SQ is 25.6. Now notice, if we look at triangle STQ, then this is actually a right angle triangle also. This is a right angle here, simply because this angle here is 90, and this angle here must be 90, because angles in a straight line add up to 180. So 90 plus 90, 180. This has got to be 90. So we actually have the hypotenuse, S to Q is the hypotenuse for STQ. And now we can find this side, S to T, which is the adjacent. This is the adjacent for that triangle. So if we have the hypotenuse and the adjacent, we're using cos of angle S, which is 26, equals the adjacent, which is the unknown, it's side ST, over the hypotenuse, which we calculated as 25.6. Now we want ST. Now notice ST is being divided by 25.6, so we have to multiply both sides by 25.6 so that the 25.6 denominator cancels. So ST is 25.6 times cos 26. So ST on your calculators we'll find as 23.0 in length. Okay, now we have that equal to 23.0. We can now look at triangle STR. STR. STR, where this is 23. We don't know this side, but we don't need it because we have the angle here. It's 26 degrees, and we're trying to get TR, this side here, the unknown, call it X. So we have to involve X, it's the opposite, and we have the hypotenuse. That's sine. Sine over angle is opposite, unknown, over 23. Again, we have to multiply both sides by 23 to cancel. So times 23. So X, or unknown side, T to R, or R to T, whichever way you want to look at it, will equal 23 times sine of 26. Okay, on the calculator, what does that give you? So we find that is 10.1. Okay. You can always go over this video anytime you want and pause and rewind if something wasn't quite clear the first time. So let's move on. Okay, so here we have it. Okay, example 3. Piece of plywood is cut into the shape shown. Calculate the dimensions. Let's just see what's going on here. Okay, so we need to get a pen. Calculate the dimensions of the plywood. So we're given one side. We've also got this side because this double dash means it's indicating that both sides are equal. So this is also 6. Now we can chop this into a shape that we might recognize here. If we bring this down straight to the bottom, create a right angle triangle, we must have the same side over here. 6, the same as 6. So 6 and 6, this is a square. That part is 6. And how about this triangle? We really need to find, we'll call this, let's call this M. M. Pen's not working very well, sorry about that. And if we call that M, we're trying to get DM. And we're also trying to get AD, so we can then add up all the sides and get our perimeter. So let's calculate AD first. This is going to be the hypotenuse for this particular triangle. So we're trying to involve the hypotenuse. We'll call it X for now. And we're trying to use the angle and the opposite side to the angle. This is DM is the adjacent. Alright, so we're going to use the opposite and hypotenuse. This means it's sine of 68 equals the opposite over our unknown X. Again, remember we can swap these two. So X becomes equal to 6 divided by sine of 68. So you can plug that into a calculator and you'll find the answer. The other thing we can do here is find DM. DM we can call it Y for a moment. And we know we have to involve this time the adjacent. and the opposite and adjacent is tan. So tan of our angle is going to be equal to the opposite over the adjacent. And remember again, we swap. So y is going to equal 6 divided by tan of 68 degrees. And you can calculate that value also. And if we just scan down here, we'll find the answers to those two questions below. So they've calculated our x, which is 66.5, and our y down here as 2.4. So now all we have to do is add up all the sides, x plus y plus 6 plus 6 plus 6. And final answer here is, there we go, it's 8.4. That can't quite be right, can it? Let's pause the... Oh, sorry about that. They were just asking about the dimensions, not the perimeter, which I thought it was. I misread the question. So there you have it. And now what I'd like you to do is, before you come to class, I'd like you to go back to the beginning and build your skills. I'd like you to do 1A and also number 3, and then we'll do the rest in class next day. Thanks for watching.